No, stop that. Let's do this properly. No more unregistered Hypercam 2 rubbish. I don't know, the way people used to do that. Anyway, installing Z88DK so we can compile C code and run it on a Spectrum next isn't difficult if you know the procedure. Watch this all before trying it. You can do some parts out of sequence to make your life easier, but they're shown in this order because it makes the most sense. I recommend watching this video at least 10 times, it really helps with engagement. Also, this isn't newbie C programming tutorial. I'm literally just showing you how to install the tools. What to do after that is not in the scope of this video, but if you want programming tutorials, let me know in the comments. To get through this tutorial, you'll need the following ingredients: a PC with Windows 10 or 11 that's up to date, a copy of the Z88DK sources, and either real Next hardware or an emulator. To make this as accessible as possible, I'll show you how to set up the emulator. And then you'll need Visual Studio Code. There are other editors, but this guide is specifically designed with VS Code in mind because it just makes everything so much easier. We're going to be using Linux to do this, so be prepared to dip into the Linux terminal, but it's not that difficult or involved. You don't need to dual boot Linux, you don't even need to install a virtual machine or any other faff, because providing you've got a modern PC running Windows 10 or 11, you can make use of the amazing Windows Subsystem for Linux. By the time we're done, everything will be inside Windows, editing code using VS Code, running it in a Windows Next emulator, and interacting with it through a command prompt inside VS Code. It's like you'll just open VS Code and work everything from inside it. So to begin, you need to install and activate Windows Subsystem for Linux. It's built into Windows 10 and 11. You just need to open a command prompt and type in this little command. That'll do it, and it'll do everything. It won't harm or change your Windows installation. It's not going to change anything about your PC's config. It's not going to boot with some dual boot or anything like that. You'll just get Ubuntu installed in a sort of virtual machine thing. It's also available from the Microsoft Store of all places. Yes, Linux is on the Microsoft Store. That's possibly the only actual use that place has. Well, apart from also being somewhere to get Windows Terminal from, because you'll want that too. We're not using rubbish old command.exe anymore. We're not even using PowerShell, sort of. 2022 is the year of the Linux on Windows desktop. We're going to make it happen. The first time you run Linux, it'll do some configuration and then give you a command prompt. You can just shut it. Open Windows Terminal instead. It's much nicer. It's got tabs and everything. This is not a virtualized Linux like you might be used to, so you can just shut and open terminals as you want. Just pretend they're DOS boxes. There's no need to shut down Linux carefully. It's all handled for you. So let's just pause for a moment and look at what we've done. Without any effort, there's now a full-featured Linux system on your machine, installed in a neat and tidy hard disk image, stashed somewhere on your boot drive. And it's real Linux, not some weird simulation, so it can do anything a standalone installation of Linux can do. It's up to date and fed from the same repositories that the real sort of installations use. It's not some Microsoft clone. It also, as we'll see in a bit, have full access to your Windows system, and you can even run Windows applications from within Linux. It all sort of works together very neatly. Now that we have Linux installed, let's get the compiler working. Now, watch this part completely before trying it, okay? Don't just follow along, because there's different bits and pieces that you can get tripped up with if you're just watching. You'll need to visit the Z88DK website and navigate to its GitHub repo. The wiki is the place to go on GitHub, and from there, there's a link to the nightly build. There's a lot of builds listed because they just keep them all. Scroll all the way through it, sort of somewhere in the middle will be one called Z88DK latest.tgz. We want that file, but don't download it because we don't want it in Windows. We need it inside Linux. So instead, just right-click it, copy its link. We're going to use wget in Linux to download it. And you just type in the little command line that's on the screen. Once that's done, go back to the install instructions and scroll all the way down to the Linux Unix part. Now this is typical Linux stuff, right? If you've done this before, you understand what's going on. If you've never done it before, this can look quite intimidating, but it's not. It just looks more effort than it really is. On your Linux terminal, you're going to type in quite a long command line, and I'm showing it on the screen now. There's a lot of text, but all you're typing in is the sudo apt-get install, because that's how you run the package manager, then a list of all those packages listed on the website, one after the other. Just stick them all one after the other with a space between and hit enter when you're done. It'll then do a load of stuff and install it all for you. You don't need to know what's going on. All it's doing is installing packages that we need. The only important part is that it doesn't stop with any sort of error. If it does, it's probably because you've spelt something wrong. Just go back and try again. You're not going to harm anything. Now we need to uncompress the Z88DK sources. First though, and this is a really important tiny point, when you open a Linux terminal, it will start off in some random folder that's inside your Windows profile. You need to go into the home directory of your Linux user. Do that by just typing cd and hitting enter, and you should go into your own directory then. If you miss that bit out, Z88DK will end up being installed in the wrong place and nothing will work and we'll all get very confused. So, making sure you're in the correct place, uncompress the source using this fun little command line. Okay, I've put this on the screen as well. Long file names in Linux, you can tab complete to avoid typing them in. And once it's uncompressed, you'll get a directory that contains all the source code for Z88DK. Now we need to go inside that directory and set up the build environment. The commands are listed on the website. You just literally type them in. And I'm putting them on the screen here as well so you can see them. Okay, all we're doing is setting 2 environment variables and making the build script executable. That's it. Before running the main build script, there's 2 things to understand. Firstly, this takes a long time. I mean, it took about 40 minutes on my PC. So don't start this if you're in a hurry. It won't finish quickly. And if you're on a laptop, maybe go and plug it in. Secondly, the way I'm about to show you will fail partway through, so keep watching before following along. You see, while this is building, 2 things are happening. The first is that we're using the native C compiler on the Linux installation to compile the source code for Z88DK. Z88DK is a C compiler written in C, so we're compiling it with a C compiler. I really want to get computer science on you at this point because compilers are fascinating things, and Turing-complete programming languages, which is what C is, it literally means you can describe the language using itself. They're also really interesting. But I won't, that's not this video, and I could go on for an hour about that stuff. We'll just carry on. Leave a comment though, if this really low level stuff is fascinating to you as well. Just let me know, there must be other weirdos out there like me. Anyway, the point is that after compiling the C source for the compiler, using your system C compiler, we end up with a C compiler for the Z88 CPU. Got that? C compiler is only half the tools though. We also need libraries. So the second stage is to compile the libraries using the new compiler. Z88DK isn't installed in the same way other Linux tools are though. Normally, after compilation, you type make install and the files will get sprinkled into certain system directories wherever they need to be. Z88DK lives completely in its own directory where you just uncompressed it. So we need to add that location to the system path so that tools and things can find it. Everything I'm doing assumes you've uncompressed Z88DK into your home directory. So yeah, look, you see, it got this far and it failed. If you look at the errors though, they're all moaning that ZCC can't be found. ZCC is the actual compiler from Z88DK. It's just compiled that and is now trying to run some tests to see if the compiler works. But it can't find the compiler because the system path doesn't contain this folder. So what we need to do is set up the system path. We do that by editing a file. This file is called .bash_profile and it lives in our home directory. If you've not used Linux before, bear with me, this is a little bit rough if you've not edited files before. Linux uses config files that are often hidden from view simply by the convention that they start with a dot. It's not the same as in Windows where you have like a file name and a dot and a 3-letter extension. And there's 2 main text editors. One is called Nano and is easy to use. You can literally type nano.bash_profile and it will create the file and let you edit it, and it's got help on the screen. The other one is called Vi and it's pretty user hostile. But my many years of using Linux, that's the one I use. So somewhere and somehow you need to edit a new file. I'll show you how to use Vi, but an alternative is to skip ahead in this video to where I show you Visual Studio Code being installed, and you can use that instead. So rather than just blindly following this step by step, go skip ahead, watch the rest of the video, and then you can put this together in a way that makes sense to you. But however you do it, we need a plain ASCII text file with Unix line endings called .bash_profile in your home directory, which is this location on the screen. And there's only 2 lines we need to put in it. So if you run Vi and you don't know what to do next, press I to go into insert mode, type in all the stuff, and then use the following magic incantation to quit and save. The escape key, a colon, W, Q, and the enter key. Don't question it. Once that's happened, we're done. And don't worry, we'll get Visual Studio Code installed and you won't have to touch Vi ever again. If you did it right, you should be back at the command prompt. Now to save closing and reopening the terminal window, we can make the current shell load those new environment variables, because so far we've not done anything with them. So what we need to do is make our current environment know these new variables. To do that, we just need to use the source command, as is shown on the screen. Of course, you're probably hopefully watching this before starting, right? So you now know how to install Visual Studio Code to edit the file before even beginning, and you won't make the same mistakes. This is why it's helpful to watch the whole thing. Now, I did it this way because it's the order of things in the instructions, and it kind of logically makes sense to install Linux, install the compiler, set the compiler up, and then set up an editor and an emulator. Also, if Z88DK is going to break, it's going to break at this point, and I wanted to show you it breaking so that you could see it and how to fix it. It's not a problem if it fails, because you can just rerun the command and it will recompile it. The only way this can really fail is by user error if you type something wrong, or if for some reason the current version of Z88DK doesn't build. But I've never had that happen. I think they check it before releasing it. Now, Z88DK is not the fastest compiler out there. It's going off to compile libraries for pretty much every Z80-based system in existence, and a few extra ones. I mean, look, if you've got an Altair 8800 like we all do, just sat around, you can use Z88DK to write code for it. Or what about a Jupyter Ace? You know, go forth and write C code. Or a Triumph Adler Alphatronic PC, which I have no idea what that is and that it even existed. Now, I know this takes ages to compile, but it's worth watching a few, just to see all the weird machines that exist. Bonus points if you've got some. Oh yeah, watch out for Windows updates popping up, you know, and don't hit restart now, otherwise you'll have to start again. And hey look, there's us, Spectrum Next, finally got there. Along with the Storm if you can hear it. This is not Storm Eunice, this is the next one. Storm Franklin or something. Right, finally, it'll stop, the compiling. Hopefully the Storm stops as well. And it should just finish without any error messages, leaving you at a command prompt. So now what? Well, let's write a test program. So if you're following along rather than jumping around the video, I'm sorry, but you're going to have to use Vi again. Or just, you know, skip ahead, watch the Visual Studio Code bit, come back. So type out the test program that's on the screen, compile it using the command line that they show you. I'm messing around here trying to remember all the switches to compile it as a next program. I can't quite remember them all. What I've got is a make file that does all this for me. I literally just type make and it does it. So interacting directly with the compiler isn't something I do quite often. I'll tell you that in a future video because that's like a whole thing by itself. For now, if it compiles without crashing or giving any errors, it's done and it's working. You've got a compiler. You are like 90% done. I'm assuming you don't own a Next, or that if you do, the idea of swapping SD cards in and out the machine as you compile code is far more effort than you can bear. The point of all this is to shorten the time between writing code and having it running. So you can try an idea and see it working or see it fail and iterate really quickly. So we need to use an emulator. I like emulators with simple names that people can pronounce. So we're going to grab CSPect. It lives here on this website, and you might encounter a bit of a weird issue that's very frustrating. Windows thinks it's malware. No idea why. Something to do with the way it opens and manipulates files or something. It's a false positive either way. At one point, Chrome thought the entire site was full of malware and wouldn't let you even visit. That seems to have gone away now. All you need to know is that there's no malware in CSPect, it's completely safe, harmless, it's a Next emulator. But your system might need a bit of convincing that it's safe to install. Well, we're not even installing it. We're just trying to download the thing first. And that involves calmly telling Windows just to chill out a bit and download and save the zip file. I had to right click it and do open in new tab so that it forced it to save it. Otherwise Chrome was just silently ignoring me clicking the link. When you uncompress it and run the exe, you'll get some more firewall junk on your screen. Just click whatever makes it go away. And that's the emulator. It doesn't need installing, it just needs putting somewhere in a folder. So you can double click it and it should open up. There are things to set up in it, but they're also not relevant if you're trying to run a Next binary directly. Like there's one in there called beast.next, and there's a batch file that runs it. If you double click that, it should just start working. So now we've got an emulator and a compiler. Now no one's saying edit source code using Vi. If you're not saying, you're done, finished. Well done, you can go and have fun with the stuff now. Although I suspect you don't need this guide if you're that advanced. So thanks for sticking it through this far, it's really cool. Hope you found something interesting. The rest of us, well, if you're enjoying this video and the way I'm clearly explaining the steps, give it a like, it really helps things out. It'll let other people know it exists. Now, a compiler is only one part of the dev kit. We need to now install Visual Studio Code for Windows to get a modern editor that we can set up and make it all nice and convenient. Visual Studio Code comes with add-ons that we can enable. And if you jumped here from the previous parts, then keep watching because you can then go back to where you came from to continue installing. And first we'll need Visual Studio Code, which is available on their website. Get the Windows version and just install it like any other app on your computer. After running it, you'll need to install this extension that I'm showing on the screen and then configure it. It's really quite easy to do this bit. And now you've got an editor in Windows that can access the Linux installation just directly. There's no weird logging in or anything needed. It can see the folders. You can even open a terminal inside Visual Studio Code to do any command line things like running the compiler. So you don't even need to open the Windows terminal. It's a nice sort of contained system. A finishing touch is to map the Linux system as a drive in Windows to make copying files in and out of it easier. Windows thinks your Linux installation is a network drive, and you can find it here at this like weird URL. On my screen, ignore Debian, I've got 2 instances installed because I was playing around. The Ubuntu one is the one that I'm using. And you know, this is now an interesting idea. You don't have to use this just for Next development. You know, do you like to develop for other old machines or machines that have GCC based compilers? Well, Windows Subsystem for Linux can be a good way to keep them separated. So there we go. You now have a clean and tidy, organised way to develop C programs for the Next and the ability to easily run the code in an emulator. More importantly, I hope you've got an understanding of how each part works. There's plenty of scope for customising this to your particular liking. One point to note though, there's no need at all to upgrade Z88DK. It comes out nightly, but you don't have to install any other versions. It's a bit like if you've ever used Unity, don't upgrade it halfway through using it because things will weirdly break. If you've got a real Next, swapping SD cards after each build will get tedious. In a future video, I'll show you how I set up a handy little tool called NextSync that copies files across my network directly into the Next using Wi-Fi. So for now, I'll leave you to go and play. Go grab some of my code from previous videos. It should just work if you use Git to download it, and you should just be able to go into the source directory and type make, and that hopefully should compile it, because that's all I do. This is the system I'm using. It's not a different version that I've just made for an easy video. This is my dev kit now that I've just been setting up. And finally, this is the part of the video where I remind you to press the thumbs up button if you liked it, and if you're new, subscribe. I'm going to do more of this kind of thing. And until next time, See you later.